Today we're going to talk about T-intervals, and you should have learned about Z-intervals to this point. And just like the difference between a Z-test and a T-test, you do T when you do not know the population standard deviation, which is an unreal expectation. So these are more lifelike situations. We're going to start with an example, and from our textbook it's 1121. I'll just put the key info down since you might not have your book in front of you. And we're going to do a T-interval for this situation. This is about a bank who wanted to know if they removed a fee, if people would spend more money. What they found out was they sampled with a simple random sample 200 people, and that should take care of our conditions right there. It was a simple random sample, and they asked 200 people, which is a large enough sample to normal out even the most unnormal population. So we're good on our conditions as far as inference go. They found an average increase of $332 with a standard deviation of $108. And the question is, what is a 99% confidence interval for the mean amount of increase? Okay, so we're going to do this first by hand and then by calculator and see how the two answers compare. If you're doing this by hand, the formula for a T confidence interval is x bar plus or minus, x bar is just the average that we got, that's going to be our 332, plus or minus T star, which is our critical value, times S divided by the square root of n. And you'll notice the difference between this and the Z intervals we used to do. We're using T star instead of Z star, and we're using S instead of sigma. When we do not know the population standard deviation, in a way you kind of just use the 108 and assume that it's pretty close to the population. If you ask 200 people, then it should be pretty close to the standard deviation of the population. However, you can't just make that change with no consequences, so the consequences of making that change are we're going to use this chart for T values instead of using the bottom line when we assume infinite degrees of freedom. We're going to use the proper line from this chart. Okay, so let's plug in what we know. We know that we had an average of 332. So what we're going to be doing is creating a little window around 332 where we are pretty sure that the actual number is within that window. Okay, T star. So we need the 99% level with the proper number of degrees of freedom. Now we have a sample size of 200, so technically we have 199 degrees of freedom. That doesn't fit in this chart very well, so the nearest level up would be 100. So we have to skip a long way, but that's all right. At the bottom of this chart, you'll see these values are pretty much the same. So we're going to be using the 100 line, and we're going to go over until we find 99. So if you follow the 100 line over till 99, you get 2.626 right here as your critical value. All right, so 2.626. Make sure you understand why that value. There's a lot of numbers in this chart, so make sure you understand why. We're at a 99% confidence level. We are using 100 degrees of freedom. So find the intersection of these two, and they intersect right there at 2.626. Okay, so back to our problem. T star, 2.626. We're going to multiply that by the sample standard deviation of 108 divided by the square root of 200. So let's do this by hand first. All right, so in my calculator, I need to find two numbers, the lower end and the upper end. The lower end is going to be 332 minus 2.626 times 108 divided by the square root of 200. And we get the lower end to be 311.945. And since this is in dollars and cents, let's go to 311.95. Okay, then the upper end is going to be that same calculation except a plus. If you didn't know this trick, if you hit second enter, you get the same line back. And I want to add that margin of error. Everything after the plus and minus, that's all called the margin of error. The s over the square root of n, that's called the standard error. So some of these terms are important to know, so for when you read them, so you'll know what's being discussed. So if I add the margin of error, I get 352.05. So the context is important. You need to be using context whenever you can. And here's the sentence. I am 99% confident that the true increase in spending is between 311.95 and 352.05. So part A of this question was to do a significance test and see if the bank could be sure that this change caused an increase. And not only are they darn near 100% sure that it caused an increase, but they're 99% sure that it's in these values, which are all over $300. So we can expect, something in the low 300s to be the actual value that people would increase their spending if this fee were removed. And if you don't see the context of the question, just worry about the numbers. But when you're answering one of these, you do need to have context in your answer whenever possible. That's important for an AP question, to show that you really know what these numbers stand for. Okay, so let's do the same thing in the calculator and see how it might vary a little bit. All right, so if you go to Stat and Tests, what we're doing here is a T-interval, option 8 on my calculator. So I want to input stats. I don't have all the numbers. If you had the data, you would put them into one of your lists and input that. I have the stats. I know that my average is 332. I know that my standard deviation is 108. I asked 200 people. I want a confidence level of 0.99. A lot of times it's 95%. This one is all the way up to 99, and I want to calculate. So I'm thinking, here's the difference. If you use your chart, it's going to do the best it can with that many degrees of freedom. But at the bottom of our chart, we started skipping various levels. We had to go all the way from 199 down to 100. Your calculator or a computer should give you a little bit more of a precise answer. So here is the calculator version. It goes from 312.14 to 351.86. And you can see, even in skipping 99 degrees of freedom, we moved 19 cents on the lower end and 19 cents on the upper end. So that difference, this 2.626, cost us 19 cents in our interval. Now the context would be the same. I would have the exact same sentence except these two green numbers in place of my two old numbers. All right, so if you knew z-intervals and you were able to find and interpret those, then you should be in pretty good shape with t-intervals. Just understand the differences. We don't know the population standard deviation, and we have to choose the proper line from the chart. And if you're doing it by calculator, the difference is very, very minimal. Okay, so that was 11.1 part 2. Our next video will be on 11.2 two-sample t-tests, and we'll call that a video. So this is Young. Have a statistically significant day.